cool. Now we get onto the triangle. Okay. So here's a triangle that I've got here. Okay. Now I'm going to put this here, but we then encounter a problem. Okay, because how do we go from the square to the rectangle? We said, well, you divide it up into a whole bunch of squares, and then you have this many this way, and then you multiply. Okay? But you can't divide up triangles you can't fit squares into it. You always have gaps. And you can't fit rectangles into it. You always have gaps. So what do? Yeah.
You half the base and times the height.
Okay, now you're giving me the answer, but you're not telling me why it is the answer. Yeah.
Because a triangle is like a square or a rectangle cut in half.
Okay, all right. Let's get on this idea again. I think there's some issues with it, but we can tease them out. We're on the right track. This triangle, I can't divide it up into rectangles or squares. But I can divide a square or a rectangle to get a triangle. So I want to go in reverse, right? So to do that, I've got some dimensions on here that will help me. So, there we go. So what have I got here? Just as before, I've got an up-down, right? But instead of calling it length, we call it height. So I'm going to put an H on there. Okay. And then across the bottom, it's B as well, but it's B for base. Base. Okay, drop the base. Now, where is the rectangle or the square that this comes from? Okay. Now, you've got to be careful. Let's come back to this rectangle we did here. Okay. Just suppose this was it, and I divided it across. Okay. So for instance, I might do this. All right, there you go. So now I've got a triangle, right? But I've got a very special triangle. See this triangle here? This one at the top? What's this angle in the corner?
Right angle.
It's a right angle, very good. It's 90 degrees, right? Now, not every triangle out there has a 90-degree angle in it. For example, this one does not, right? So therefore, you can't go ahead and just use these rules all the time because this triangle doesn't obey that particular rule. So I have to do something else. Yeah. Say it again.
Can we move back there, please?
You can wait. You can wait. So here's what I'm going to do. You see how I've divided this particular triangle up in half with this height. Okay. So in this triangle, I now have two triangles. Does that make sense? And I'm actually going to number them, right? So I'll call this one number 1 and number 2. Right? Now, if you have a look at the first triangle over there on the left, you can see that if I copy that triangle, like so, and then just turn it around a little bit, I can shove him up against there like so. Okay? So this is a copy of triangle 1. It's the same area. That's really important, right? And if I put them together, triangle 1, now what have I got?
Rectangle.
That's a rectangle. And you see, I've got a right angle here, just like I was talking about before. Okay? So it doesn't take that much imagination to see that I can play the same game with triangle 2, right? So let me make sure I get the orientation, right? I think it's going to look like this. There you go. So this is a copy of triangle 2, again, spun around and matched up so that what I get is another rectangle over here. So this is triangle 2 as well. Okay. So now compare the rectangle with this yellow triangle down here, right? Because that's what we really want. The area of this triangle. Well, when you think about the whole rectangle that I've made by adding up all of these triangles together, what's the area of that whole rectangle? Stop. The whole rectangle. Yeah. L, which in this case is this height, times B, which is this base. Yes? B times H, which is that whole rectangle. Right? The whole rectangle. But I don't want the whole rectangle. If I get rid of these extra props now, right? This is exactly equal to what I've left. I've taken half of it away, right? In fact, you know, here you go. You can even see it if I put it here and there. There you go. They're equal. Okay. So, therefore, it's divided by 2. And that's where you get your familiar half base times height. Now, you learnt this 2 years ago. Okay, this is in year 8. But the reason I'm laboring this is precisely because of the answers that got called out. You can't just quote these. You have to know why they are, right? These are basic shapes. We can understand this, but you want to understand the reasons behind it. Right. One more shape. I mean, there are more, but we're just going to do one more today. This guy. Who's this guy?
Rhombus. Kite. No.
What do you think?
Rhombus, rectangle.
Starts with a P?
Parallelogram.
It's a parallelogram. I can tell you it's not a rhombus because clearly that looks longer than that, right? Can you see that? Parallelogram.
So that's a kite.
Why is it not a rhombus? Sorry?
It's not a rhombus because the sides aren't all equal length.
So that's a kite. That's a kite.
They are.
I can tell you it's not a kite because, see, and we'll actually have it, we'll mark this on. So here's your parallelogram. You can cut one out. Okay. Oh, 1 second, because I'm in the middle of answering another question, so you will have to wait. Have a look at the sides, because there are some equal sides, there are some pairs, but which ones are they? For instance, see this one up here? What's it equal to? That's exactly right. The opposite side. Okay. When you have a look at the other pair of sides, they're also opposite, right? Now, when opposite sides are equal, that's a parallelogram. If we wanted a kite,
Oh, wouldn't it be like?
Diamond.
So isn't it like the?
here's a kite,
Yeah.
right? It's still got two pairs of equal sides, but where are they? They're not opposite, are they? They're adjacent. Very good. Right? So that gives you a kite. This gives you a parallelogram. Okay, Amy.
Is a rhombus and a diamond the same thing?
No.
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 That's like a quarter rhombus and a
Um. Well, kind of. See, the problem is diamond. The word diamond, it's used ambiguously. Like for example, in baseball, there's a diamond. You know what shape the diamond's in?
Rhombus. Yeah.
It's kind of square, really. You're like, so it's like what? Diamonds don't use the word diamond, okay? Because it could mean, doesn't quite say the same when it's like shine bright like a rhombus. Like it just doesn't work. All right, can we move on? Is that all right?
Let's keep talking.
All right, so here's my parallelogram. Now, what I would suggest you do is, despite how beautiful this is, and this actually is also a parallelogram, but I actually think this looks very much like, it looks like a rhombus, right? Which means that, like, you might think that you can use the rules of a rhombus, which are different. We'll get to them on Friday, right? With them, which you can't, okay? So that's why I deliberately made this longer than this edge, so that you can see that it's not a rhombus. Whereas with this one, it's kind of dicey. Keep using it, it's fine. But I would wait. Yeah, that's my point. They're close. Okay, now, what are we going to do here? Would someone like to give me a suggestion? Jade.
cut off the end. Sorry. Cut off the end and put it on the other side, and it makes it a rectangle.
Okay, cut off the end. Cut off the end. So where is this end? So for example, right? It's kind of like this, isn't it? By the way, this has a special name. You should note it down, right? See that line which gives us a perpendicular height in this case, right? That word perpendicular is important. When it's perpendicular and you get that height, this line is called the altitude. Just like altitude in the air. Okay? So what you're going to do is create a similar kind of thing here, the perpendicular height. Okay. Now, if I get my prefabricated one here, here's where I see. Let me try and get my finger out of the way. Okay. Here's where I see us cutting off one end, right? And that vertical line there, that's going to be the altitude. Now, what I want to do is move this guy around to here. Okay. Now, when I do that, here's what I should produce, okay? Here is what's left over after I've cut off that triangle on the end. Can you see that? It's been lopped off. I might put it in dotted lines so you can see what's happening. That's where the triangle used to be. And now I'm going to rearrange it over to this side here. So now you can clearly see, right? Remember how did I choose this vertical line? Why did I cut it along this way Why didn't I cut it like some other way? What was special about that line?
It wouldn't have made a difference if you cut it on the other side.
Say that again.
It wouldn't have made a difference if you cut it on that other side. You could just put it on the other.
Okay, true. Remember, right, just like in the triangle,
Unless you flip it upside down.
yeah, I'd need to do some weird rotation stuff, wouldn't I? Or if I cut this way, I wouldn't get a rectangle. I'd just get another parallelogram, which is the same problem that I started with, right? So if you cut this line perpendicular, just like this altitude, then when you bring it over here, it'll be perpendicular over here as well, which is just like a rectangle, okay? So now I've got my base, I've got my height, right? Which are the same as this base here and this height, okay? So therefore the area of a parallelogram, and make sure you spell it right, it's got an O in the middle, okay, is equal to, very simply, the base times the perpendicular height.
BPH.
Make sense?
If we wrote BPH, would that be wrong?
Yeah, because pH would be 2 letters, and in algebra, every letter is its own number. So we've only got 2 things here. In fact, by the way, if I make this a little clearer, see, s squared is just s times s, right? Do you remember how I made a point earlier when we said area is the space taken up by a two-dimensional shape? You can see the 2 dimensions every time. Look, 1, 2. 1, 2. 1, 2. 1, 2. Every time you're working out an area, you'll get 2 dimensions.